Okay, our last lesson is on the factored form of quadratic relations. Now, we've learned three different forms. We learned the vertex form, which is used to find the vertex easily. We learned the standard form, which is used to find the y-intercept easily, but it's also used mainly for simplified algebra, making it easy to find out x and y values. Now we're going to learn the factored form. And this form is mainly used to find what we call the zeros or the x-intercepts of the parabola. And depending on the type of question you have, the x-intercepts are the more important thing to solve for than the y values or the y-intercept. So this is a very useful form. Now, the standard form you can see is y equals a, x minus r, x minus s. And that a is, again, the same a that you find in the vertex form or the standard form. The r and the s would be the location of the x-intercepts. So they would be at r0 and s0. The axis of symmetry passes through the vertex, and the axis of symmetry can be found between the two zeros. It'll be at the exact midpoint between the two zeros. So if we know those two zeros, if we know the r and the s, and we find the average of the r and the s, that will give us the axis of symmetry. And once we know the axis of symmetry, we will know the x value of the vertex. And if we substitute that x value into our quadratic relation, we'll find the y value of the vertex. So converting quadratic relations into their various forms is an important skill. And you'll be doing that depending on what you need to solve for the quadratic relation. Let's do example 1 to see how this could be done. So if we were asked to determine the x-intercepts of y equals x minus 5, x plus 3, first we look at the form, and we see if this is something we can determine directly from the form. Because this is in our factored form, or our x-intercept form as it's sometimes called, we know that we can easily solve for the x-intercepts just by looking at the equation. It's x minus 5, x plus 3, so that our first x-intercept is at 5, 0. Our second is at negative 3, 0. Remember that because there's a plus in front of that 3, we have to subtract a negative 3 in order to make that a negative. But let's see, for example 2, this one's a bit different. It says that we have to find the x-intercepts and the step pattern and the vertex of a quadratic relation, but it's in our standard form, and we can't find any of those. We can find the step pattern, but we can't find the x-intercepts or the vertex easily from that form. So what we'll do is we'll convert it to factored form, because factored form will help us find the x-intercepts easily, and we can find the vertex relatively easily from that form as well. So we start off by factoring out the 9, and that gives us 9 x squared plus 4x plus 3. And we factor out that trinomial, we end up with 9x plus 3, x plus 1. So our x-intercepts are at negative 3, 0, and negative 1, 0. A is 9, so the step pattern is going to be 9, 27, 45, and so on. Now to find the vertex, we find the midpoint value between the two zeros. So minus 3 and minus 1, we add those together, divide by 2, we end up with negative 1. So our axis of symmetry is x equals negative 1. Substitute that negative 1 and we into our equation, and we end up with our vertex, which will be at negative 1, 0. So that's how you would use converting between forms to solve for certain types of information on a parabola. Now let's go to the support questions. So the first one here says determine the equation of the parabola represented on this graph. Now looking at this graph, what I can see is I can find the vertex. So I could write this in vertex form, but because we were learning this in intercept form, I'll explain how to write it in intercept form. So there's a 0 at 2, 0, and there's a 0 at what looks like minus 3, 0. So this would be x or y equals a x minus 2 x plus 3. Now we need to determine our a. So the vertex is at -1, -4. And as we go to 0, we go up by 1. So if our a is so this in factored form would be y equals x plus 2 x minus 2 x plus 3. In vertex form, just for fun, we can say this is going to be y equals x plus 1 squared minus 4. And our a is 1 for both of those. Let's look at question 2. This says to plot the quadratic relation. We'll do 2b. So to plot this quadratic relation, what we'll need to do is determine what are we going to make this look like in terms of our Cartesian plane. Well, our zeros are going to be on the right side. So let's start by making a let's show you there. Let's start by making a Cartesian plane like that. And for this Cartesian plane, there's my ruler. I don't know exactly how long it needs to be that way, but I do know that I'm mostly going to be operating on the right side here because I have both subtractions. And we have y equals x minus 1, x minus 5. So at 1, 2, 3, 4, 5, and 5, I'm going to have my two zeros. So I'll just label every second. 2, 4, 6, and so on. Minus 2 and 2. Now, I know that my vertex will be at the midpoint between these two values. So let's write this down here on the side to see where my vertex will be. So it's going to be, my axis of symmetry is x equals 1 plus 5 over 2. That's going to be 6 over 2, which is going to be 3. So this is my axis of symmetry right here, going through that line. And if I put 3 into my equation, 3 minus 1 is 2. 3 minus 5 is -2. And that would get us to -4, which means that we'll be right here. That's my vertex. When I go when I go to the left once, I go up by 1 because my a is 1. And I just kind of draw my parabola like that. And at the end of the parabola, I write down what the equation is. X minus 1, x minus 5. For 3, determine the x-intercept, step pattern, and vertex for the following quadratic relations. In a number of these cases, you'll have to factor before you do any of that solving. So I'll just mention it for A, B, C, and for A and B and C, you have enough information to write out your x-intercepts. C, you'll have to do a little bit of factoring first. And then using your x-intercepts, you can find your vertex. For D, E, and F, you'll have to either expand first and then factor, or factor. And then you can write your x-intercepts, your step pattern, and find your vertex from those as well. Question 4 is an application type question. So it says here we have a cannonball that's launched upwards. We're given the height equation. So let's do 4A. It says determine the height of the cannonball before it is launched. In this case, that means that our t would be 0. So that means our -4 times 0 squared plus 32 times 0 plus 36 gets us to h equals 36. So our height is 36, I think it's yards. 36 yards. For B, determine the height of the cannonball after 2 seconds. So minus 4 times 2 squared plus 32 times 2 plus 36. This is going to be negative 16 plus 64 plus 36. Adding these together, we end up with 84 yards. For 4C, determine the maximum height of the cannonball. So in this case, we need to factor to figure out what our vertex is. And minus 36 would be negative 9, I believe. I think I did 32 wrong. 32 is actually minus 8. And then factoring even further, I end up with t is minus 9, t plus 1. So the maximum height of the cannonball is going, I know my axis of symmetry is going to be at the midpoint of the zeros, so t equals 9 plus negative 1 over 2, which is 8 over 2, which is 4 seconds. And when I substitute 4 into that equation, 4 squared plus 32 times 4 plus 36, I end up with negative 64 plus 128 plus 36. So 64 plus 36 gets us to 100 yards, right on, 100 yards. And now for 4D, how long was this cannonball in the air? Well, if it was launched at 0 seconds, let's figure out when it hits the ground again. And if we look over here, we have two possible values. It was at the ground at negative 1 seconds, but that doesn't make any sense. It was also at the ground at 9 seconds. So it must have hit the ground after 9 seconds. Let's look at the what our assignment will look like. So basically, you'll have to determine the equation of this the parabola that's listed. It's hard to find the vertex form for this one because it's not right at an easily recognized value. So you'll have to use the factored form. You're going to have to plot one quadratic relation. You'll have to find the x-intercepts and the step pattern and the vertex for 3 other quadratic relations. And then you'll have to answer one application type question.